Hey guys, today we are going to learn how to find an angle measure on a right triangle using inverse trigonometric ratios. So if we have angle A as an acute angle on a right triangle, then sine A would be opposite BC over the hypotenuse AB. Cosine would be adjacent over hypotenuse, so that's AC over AB. And tangent would be opposite over adjacent, that's BC over AC. Okay, now if these are all true, then the measure of angle A can be found by doing inverse sine. Inverse sine of BC over AB gives us the measure of angle A. Or inverse cosine of AC over AB gives us the measure of angle A. Or inverse tangent BC over AB gives us the measure of angle A. Okay, so how do we actually use that? So here's a triangle where we want to find the measure of angle A to the nearest tenth of a degree. So here's angle A. And what we have here is the opposite leg. And here is the adjacent leg. So we're going to use SOHCAHTOA. Okay, so opposite leg and adjacent leg right here, opposite and adjacent, that's under tangent. So tangent A is equal to the opposite leg, 16, over the adjacent leg, 20. And anytime the variable is the angle measure, what we can do is use an inverse trigonometric function. So that means that A is equal to the inverse tangent of 16 over 20. Okay, so in our calculators, we make sure we are in degree mode. And we type second tangent to get this little inverse tangent here. So second tangent, 16 over 20. And we get 38.65, so about 38.7 degrees. And that is the measure of angle A. Okay, now we're going to use that to find the measure of angle C. So same picture, but now we're finding the measure of angle C. And this time 20 is the opposite leg and 16 is the adjacent leg. So we're using tangent again. So tangent C is equal to the opposite, which is 20, over the adjacent leg, which is 16. And once again, we have a variable here for the angle measure. And anytime the angle is the variable, we use an inverse. So C is inverse tangent, 20 over 16. So second tangent, 20 over 16 is 51.3 degrees. So the measure of angle C is 51.3 degrees. Now notice if I add those together, so we have 51.3 plus 38.7, we get 90. And if I add that 90 right there, we get 180, which is how many degrees we need in a triangle. Okay, so now find the measure of angle A here. So over here, I have the opposite leg, and right here, I have the adjacent leg. Okay, so that's going to be tangent again. So tangent A is equal to the opposite leg, 15, over the adjacent leg, 24. And again, the angle measure is the variable. So A is equal to the inverse tangent of 15 over 24. So the measure of angle A equals second tangent, 15 over 24. 32.0 degrees. And I'm writing 0.0 to indicate that it's not exactly 32 degrees. 0.0 kind of looks meaningless, but it's not. It tells us it's not exactly 32 degrees. All right, this time we're looking for the measure of angle B. So over here, this 18, that's the opposite leg, and this right here, that's the hypotenuse. It is across from the right angle. So we've got opposite leg and hypotenuse, and in our word SOHCAHTOA, opposite and hypotenuse is right here. So this time we're using sine. So we have sine B equals the opposite leg over the hypotenuse. Okay, and again, the angle measure is the variable, so B equals inverse sine, 18 over 27. So that's second sine, 18 over 27, 41.8 degrees. So the measure of angle B is 41.8 degrees. The measure of angle C. This 12 here is the adjacent leg, and 19 is across from the right angle, so that is the hypotenuse. Adjacent leg and hypotenuse, and in our word SOHCAHTOA, adjacent leg and hypotenuse are here under cosine. So this time we are using cosine. Cosine C is equal to the adjacent leg, 12, over the hypotenuse, 19. And again, the variable is the angle, so C is inverse cosine, 12 over 19. So the measure of angle C is inverse cosine, 12 over 19, 50.8 degrees. So solving a right triangle. When we solve a right triangle, that means we are going to find out the lengths of all three sides and the measures of all three angles. Okay, so we will know all three angle measures and all three side lengths when we are done. So we are going to solve this right triangle here. Okay, now for this angle measure, I've actually got two angle measures already, so I could just do 180 minus 90 minus 23, and that will give me the measure of angle B. Okay, and remember that if one of the angles is 90, I know 180 minus 90 is 90, so I really could just do 90 minus 23 and get the same answer as I would for 180 minus 90 minus 23. So 90 minus 23 is 67. So the measure of angle B is 67 degrees, and I'll write that into the triangle. Okay, so next I want BC. I'll call it X for now. Okay, so from this 23 degree angle, this X is the opposite leg, and 40 is across from the right angle, so that's the hypotenuse. Okay, so back to our word SOHCAHTOA. Opposite leg and hypotenuse, that is right here. That is sine. So we'll do sine 23 degrees is to 1, as the opposite leg X is to the hypotenuse 40. When it's a number down here, we do cross products. 1 times X and 40 times sine 23 degrees. So 40 sine 23 is 15.6. Okay, and this is in feet, so it is 15.6 feet. And then I need side AC. For now, I'll call that Y. Y is the adjacent leg, so I'll use the adjacent leg in the hypotenuse this time, and that is cosine. So it's cosine 23 degrees is to 1, as the adjacent leg, which we're calling Y, is to 40. So again, our cross products, Y times 1 is Y, and then 40 times cosine 23 degrees. 40 cosine 23 is 36.8. So that's 36.8 feet. So now if we look at this triangle, we see all three angle measures and we see all three side lengths. So we have finished solving the right triangle. So we'll solve another right triangle, one with a 50-degree angle. So there's my right angle. And between these two angles, I'd say this one looks more like 50 degrees. So there's my 50-degree angle. And a 15-inch hypotenuse. Okay, so we need this angle measure right here. So we'll do 180 minus 90 minus 50, or just take the shortcut, 90 minus 50, and that is 40 degrees. So this missing angle here is 40 degrees. Okay, then let's call this x. So we'll use this 50-degree angle that we started with here, and x is the opposite leg, and 15 is the hypotenuse. So that means we are going to use sine, opposite and hypotenuse. So we have sine 50 degrees is to 1, as the opposite x is to the hypotenuse 15. Okay, so our cross products are 1x and 15 times sine 50 degrees. Okay, so 15 times sine 50 is 11.5. So x is 11.5, and this is in inches. So we have here 11.5 inches, and we'll call this one y. And from this 50, that is the adjacent leg. So we have adjacent leg and hypotenuse, which means cosine, adjacent and hypotenuse. So cosine 50 degrees is to 1, as the adjacent leg, y, is to the hypotenuse 15. So our cross products are 1y and 15 cosine 50. So 15 cosine 50 is 9.6. So we have 9.6 inches right here. Okay, and we now know all three angle measures and all three side lengths, so we have solved the triangle. You are building a track for a model train. You want the track to incline from the first level to the second level 4 inches higher over a span of 96 inches. So let's draw this out. So we've got a triangle that we're going to make here. The track is going to rise from this lower level to a higher level. Okay, so here's the track, and it's going to rise 4 inches, and it's going to do so over a span of 96 inches. The train will not be able to traverse an incline more than 3 degrees. Will your train be able to handle the incline? So this incline here cannot be more than a 3-degree incline. Okay, so let's find out if this will work for your train. So here's our angle. Over here is the opposite leg, and here is the adjacent leg. Okay, so that is tangent. So we have tangent x equals opposite 4 over adjacent 96. And here we have the variable as the angle measure. So we do the inverse. Inverse tangent 4 over 96. So second tangent, 4 over 96 is 2.4. So we have 2.4 degrees. Will your train be able to handle this incline? 3 degrees is the maximum. We are below 3 degrees, so the answer is yes. Suppose you have another incline. So we'll draw ourselves another incline. So here's the track. And it's going to be an incline rising 8 inches over a span of 120 inches. Will your train be able to handle the incline? So here's our angle. Once again, we have opposite leg and adjacent leg. So that's going to be tangent. So tangent x is equal to the opposite, 8, over the adjacent, 120. Okay, so again, the angle is the variable, so we do the inverse. So x equals inverse tangent, 8 over 120. So that's second tangent, 8 over 120, and that is 3.8. Your train will only handle up to 3 degrees. This is too much. The answer here is no.